Okay, so I'm looking at the problem set and wondering what might be the easiest problem to do. Just kind of looking through it. The first function, trigonometric, second function, some type of conic section problem. 3 is a 2-digit number. I'm going to go for number 3. All right, so number 3. So I know I have a 2-digit number. So I'm going to put the 2-digit number down as x is the first digit, y is the second digit. So if it's a 2-digit number, I clearly know that x can't be 0. All right, so x can't be 0 if it's a 2-digit number. All right, so what does it say? A 2-digit number is such that the product of the digits, well, let me write this down. The product of the digits would be x times y. So let me just write a 2-digit number such that the product of the digits plus the sum of the digits, well, the sum of the digits would be x plus y. Let me keep reading it, is equal to the number. Well, what's the number? The number is actually 10x plus y. The understanding that x and y are digits, which means x and y now are between 0 and 9, and certainly x can't be 0. All right? Let's see if we can figure this out. So x, y, plus x plus y is equal to 10x plus y. Well, I'm looking at it, and I'm starting to realize that there's something I can do here. Subtract y from both sides, and then subtract x from both sides. So if I did that, what do you get? X, y is equal to 9x. Wow. Well, remember, x can't be 0. Right? X can't be 0. So I'm going to divide both sides by x. And what do you get? Y is 9. All right, now, someone says, what is their question? It says a 2-digit number is such that the product of the digits plus the sum of the digits is equal to the number. What is the unit digits? I just found it. It's 9. All right, this is the units digit, y. All right, let's go there. It was a pretty easy question to do. Let's just see if I misunderstood the question. It happens sometimes. Yeah, y is 9. All right, and did the same technique over here. All right, let's go for another problem. And I'm going to look around. And I realize an inclination here is to do something that you can do. And that should be your inclination. What can you do? So I'm kind of looking around. And I'm thinking that maybe number 5 looks easy to do. Now, I realize a lot of students are going to say, oh, limit as x goes to 0, sine x over x is 1, and just end it there. But you're not paying attention to something. It says that this is in degree mode. So what I want to do is I want to graph what the sine function looks like in degree mode. It looks like this over here. Now I want to point out, when your teachers told you about this over here, they were strictly in radian mode. And really what they said is the rate of the top and the bottom, right? I should say, maybe I should clarify that. The rate at which x on top and the rate at which x on bottom goes towards 0 has to be going there at the same rate. So remember, if they wrote something down like this, limit as x goes to 0, sine 2x over x, your job was this, to multiply the top and the bottom by 2. In this case, what you'd get is you'd see this, and I want to point out 2x and 2x are going to rate at the same rate, and then that would be 1, and then 1 times 2 would be 2. So this limit over here would just give you 2. All right, so they gave you some problems like that. They're pretty straightforward, but everything was like in radian mode. Let me get my, erase this out over here. I got troubles over here, and the reason we have to scale along the x-axis in degrees. But the y-axis is still, in some kind of linear measure there, like, some numbers. All right, let's put the degree measures down, 90 degrees. And this would be 360 degrees. This is 0 degrees. So I'm looking for a line over here, right, that going the same rate. And that's got a slope to it, though, and slope's not 1. And what would the slope of that be? So the slope of this line over here, it goes through the origin, by the way, is going to be, let's see, it would have to be pi over 180 degrees. Let me just make sure I'm making sense out of this. So the change in the y's over the change in the x. So when x goes 180 degrees, whoops, I made a mistake in my graph. Just not thinking. That's 180 degrees. Sorry about that. I'll revise. I sometimes I make mistakes and I don't realize it until I look at it. And I say, how could I have written that down? So I'm going to say equation of that line. So what I have to do, let me get rid of the degree symbol though. Let me write that down a little bit neater for you. All right, let's write this down. Well, it's almost like I'm doing this one over here. Oh, not this one, I'm sorry. I put the other one down. Sorry about that. The trick there is to multiply top and bottom by 2. And then see this thing over here. All right, well, let me do that. Limit as x in degrees goes towards 0 of the ratio sine x over x. This is going to be tricky, isn't it? Well, I got to be honest with you. The rate at which the top and the rate at which the bottom are going towards 0 is not the same rate. So I have to multiply the top and the bottom by something. It's going to be pi over 180. Pi over 180. And what would you get? Well, now, the rate at which the argument on the sine, the x, and this guy on the bottom are going towards 0 at the same rate now. And again, this is the visual of it right over here. So what's the answer over here going to be? Pi over 180. All right, kind of tricky, right? Let's take a look. That's number 5. I'm saying pi over 180. And they talk about that. And they talk about the sine function. You may want to graph that out, by the way. What I mean by that, graph out in your graphic calculator, graph out y equals sine x, and do it in degree mode, and graph out, y equals pi x over 180. And again, do it in degree mode, and you're going to see this function, the sine function, is going to look like this one over here. But again, we just went through this over here, pi over 180. All right, let me go back. I just want to describe to you what we've done so far. We've done 2 problems. We've done 3. Wasn't that bad. And we've done 5. All right. Now what I'm going to do is I'm going to look at another problem. And looking at another problem. The question is what problem you want to do. And I'm going to avoid the trig functions for the time being. I'm going to look at number 2. And the first thing about number 2, it's a conic section, but I'm not sure what conic section it is. It's either going to be in a circle or an ellipse. But they do say a and b are positive numbers. So I want to write in that form that I like to write it in, which I'll write this down for ax squared. Again, we're doing number 2 now. Plus by squared is equal to ab. All right, I'm going to divide both sides by ab. And again, I don't know what a and b are except they're positive numbers. I know that much. They're non-zero. They're positive numbers. So you would get x squared over b plus y squared over a is equal to 1. Now this could be a circle. If a equals b, this is a circle. Right? Now, if a and b are different, right, does it say that in the problem? No, it doesn't say that. I know I got a picture, and I want to point out what the picture looks like to me. And again, it could be elliptical, it could be a circle. I'm just going to say, I'm going to just draw something that looks general. I'm not saying that's a circle or an ellipse, by the way. But I'm going to put down, I know it's a conic section that's got this general shape to it. Like, I say like an oval, right? Could be elliptical, could be circular. Just say oval. And what's this point over here? This point over here would be what? I gotta be careful here, right? I know something. I know the y is 0 here. So the x would be root b. And what's over here? Minus root b, comma 0. And what goes over here? Well, this is where the x is 0. And that would be minus root a. What's over here? 0, root a. And again, I know a and b are positive numbers. What I know about it now. Now, by the way, sometimes I don't know what the question is. I got to read it. It says, a and b are positive numbers. X, y is a point in this curve. So I'm just going to say x, y is some point in the curve now. Right? It says, what's the largest value of x, y? Well, I got to be honest with you. It's either going to be over here somewhere. When I say that, it's going to be on this side. Or it could be over here. But it could be nowhere else. And the reason for that is in the other quadrants, x and y differ in signs. So I got symmetry here. So what I'm going to do is just concentrate on the first quadrant. Because if I know where that is, over here would be a symmetric point. All right, so I'm just going to concentrate on the first quadrant. And then I got to determine, they really want to know what the maximum x times y is. Well, before I go forward, I want to tell you what x has to be between. Well, it's got to be greater than 0. And it's got to be less than the root of b. And the y has got to be greater than 0, and it has to be less than the root of a. Again, I'm concentrating the first quadrant. So let's see how we're going to do that. And to do that, I know you got an xy. I'm going to get a product xy. I got to work on that, don't I? And let's think about it. Again, I know the x is between 0 and root b, and the y is between. I need to get an xy in the problem. So I'm going to write something down. I got to play around with this now. So I need an xy in the problem, though. I don't see it yet. So ax squared plus by squared equals ab. I'm going to write this a little bit differently. I'm going to write it as the root of a x squared plus the root, and this could be a dead end, squared equals ab. And I'm going to, I want to get an xy in it, so I'm going to introduce one. Root a x squared plus root b. Whoops, I made a mistake there. Root b y squared minus 2. I got to play around with this here. Hey, whoops, I made a mistake. Sometimes my pen thinks I'm trying to draw something. AB xy equals AB minus 2 root AB xy. All right, this is getting tough. Let's take a look. So what do you get over here? I think I got a perfect square here now, though. Let's write this down. Root a x minus root b y equals, I gotta be careful with this one, don't I? I'm seeing, did I get that right? Let me see, I'd get that, and I get that, minus 2. Yeah, I got that. Let me write this over here. This is gonna be AB minus 2 root AB xy. So at least I got an xy in the problem, right? I got to keep looking at this too to see where I'm going to go with that. But I know I want to get that xy business there. Let me have a moment to think. The problem with thinking is sometimes thinking doesn't really pay off, because when you're trying to think about something, you just don't get there. I got to look at that and carefully look at it and then start thinking about it. And let me take a look at that. I got to think back what I was given here. And I got to be careful, don't I? I'm thinking. I'm looking at that. I'm trying to find something easy to do here. If it was a competitive exam, I want to skip this one at this point, but I'm not going to give up so easily. And I would recommend you don't give up either. Don't jump ship too quickly. And I'm kind of looking at that. Nope, I'm going to jump ship on that. And what I'm going to do is, maybe I shouldn't erase it though. But I'm going to go back and I'm going to look at something else now. And what I want to do is I want to take this equation and I'm going to solve it for y. But again, I know I'm in the first quadrant, and that's really important. I know I'm in the first quadrant to do that. So I would get by squared is equal to ab minus ax squared. And then what I'm going to do is I'm going to divide both sides by b, and y squared would equal a minus a over b. Whoops, I made a mistake there. I'm thinking, but I'm writing something down that I'm not even saying. That would be a over b, x squared. And again, I know y's in the first quadrant, so it's a positive number. So I'm going to do plus or minus. I'm going to do this over here. I did it again, didn't I? I had x on my mind, by the way. So what do you have here? You get a minus a over, oh boy, I'm really screwing up, aren't I? But I know I'm screwing up when I write things down that not above it. I got this over here. I still don't have the xy though. I'm going to introduce it by multiplying both sides by x. So I get xy equals x times this thing over here. And again, this could be prove another dead end, but I got an xy in the problem. And over here, it was just overwhelming to me. I didn't know where to go with that at that point. So I'm over here. At least I got something that I want to maximize, right? I want to maximize this, maximize. By the way, x and y in the first quadrant are greater than 0. So I'm gonna probably write this a little bit differently. I'm gonna write x and y is really, the x is the same thing as square root of x squared when you're in the first quadrant. And this is proving to be more difficult than I expected. And what do you get over here? Well, I'm going to just rewrite this a little bit differently, and you're going to get, let's see, what would you get? Ax squared minus a over b x fourth power. And what I'm trying to do is I'm trying to maximize this. All right? And how do you maximize something? Well, really what you're trying to do is you're trying to make it as large as possible. So to do that, what I'm going to do is just to simplify it, I'm going to maximize this thing. All right, just going to try to maximize that. Let me write this over here. By the way, I know my restrictions on the x, by the way, but let me write this down. So f of x, I'm going to try to maximize what's on the inside of that radical. That's called a radicand, is ax squared minus a over b x4. I'm going to do this by doing calculus. This would be 2ax minus 4ax cubed over 3. Oh, I'm sorry, over b. Sorry about that. I think I'm just daydreaming. Okay. Where's the x going to be? And again, this is important. I know my x is going to be from 0. And the last thing the x could be is the root of b. I got to find the critical numbers now in that interval. So the way I'm going to do that is just take 2ax, set it equal to 4ax cubed over b, and then try to solve for x. Well, I'll be careful here. I'm going to divide both sides by 2 and multiply both sides by b. So I'm going to divide by 2 and multiply by b. I'm just being careful. I'm going to divide through by x. X is definitely not 0. I don't have to worry about that. And I'm going to divide by a, and a is not 0. I don't worry about that. So you're going to get, you know what? I think I made a mistake over here. Let me just get rid of that 2. I said I divided by 2, right? Let me make sure before I go further. I multiply by b, and I divide it by 2. Yeah, I think I'm okay now. So I'm going to divide by a now, and you're going to get, and x. They're both non-zero. So divide by a and x, and I get b equals, I divide it by a, right? 2x squared. So now I know that x, and again, the x has got to be between 0 and root b, is going to be, let's see, the root of b over the root of 2. That's right over here. All right. Well, I think I need to analyze it now, right? And looking at it, I want to point out what I'm thinking about now. I'm thinking about analyzing it, and some signs over here about what's this doing over here. And I guess I could take another derivative. Let me do that. F double prime now. What's that going to be? 2a minus 12 a over b x squared. You may wonder why I'm doing that. I'm trying to figure out the shape of that curve. And that's going to be a downward facing parabola. Yeah, and then look this. Concave down, so it looks like this over here. All right, so I think I found what the x is, but I did not find the y. Let's put this down. So what's it going to be? I got to find it. It's right over here. And let's write this down now. Y squared is equal to a minus a over b times, I have to square that b over 2, which would be b. I'm squaring this thing over here, the root of b over 2, which is b over 2. So y squared would equal a minus a over 2, which is going to be a over 2. So what's y equal to? And again, we're in the first quadrant, So it equals the root of a over 2. This is a long problem. Someone says, what was the question? Well, I just maximize x times y. The question is, what is it? I don't know. Let's write this down. So it's going to be root b over 2 times the root a over 2, which would be the root of ab over 2, maximum value. All right, let's take a look at the key. And that's, what number was that we just did? That was a long problem. That was number 2. All right, so I'm saying root of ab over 2, number 2. Boy, they did a long problem too, didn't they? Yep. All right, so we did it right. Let's keep going. Let me get my eraser out. I'm going to do another problem. Now, by the way, when you look at my work in the blue area, it's me typing this stuff up. I'm not really looking at the work, by the way. I'm just kind of, I'm kind of spinning my way through these problems over here. I'm exercising, right? I'm hoping there's some benefit to exercise. I think there is, by the way. The main benefit to exercise is I think you improve the speed at which you can move forward. But let me point out what I've done so far. I've done this, I've done this, and I've done this. So I need to do these other ones over here, and I'm going to write what I'm thinking I'm seeing over here. I'm going to try number 1 now, and they tell me the sine of alpha is equal to minus 1 over root 2. In my mind, I'm kind of visualizing the sine curve, and I know there's 2 places where that occurs on its path. And now I'm going to write down the cosine alpha minus beta, and they say that's 1/2. I want to try to understand what that says, by the way. So I'm going to just expand it. It's cosine alpha times cosine beta plus sine alpha sine beta. And they said it's equal to 1/2. I'll get to their question later, by the way. But what I'm going to do is I'm going to start plugging in values over here. Now, the one thing I want to point out, if the sine of alpha, right, if the sine of alpha is minus 1/2, it's in the, the 3rd or 4th quadrant, and the cosine of alpha would be plus or minus. I'm not sure which one it is, by the way. So I'm going to write that down for you. And again, this might, be a dead end for me to write that down. I might have to go back and do something later saying that's a crazy idea. Cosine beta, and the sine of alpha is minus 1 over root 2 sine beta. And this is 1/2. And I'm going to clear the fraction by multiplying both sides by root 2. So I get plus or minus cosine of beta minus sine of beta equals root 2 over 2, which is the same thing as 1 over root 2. So let me write this down. Plus or minus cosine beta minus sine beta is equal to 1 over root 2. Let me see what their question is, though. So it says sine alpha equals this, cosine blah, blah, blah equals that. Beta is a positive number. What's the minimum value of beta? What's the minimum value of beta? So I want a minimum value of beta, and beta is a positive number. All right, what I'm going to do is I'm going to square both sides. All right, now so why would you do that? I'm trying to get something that looks like an identity to me that I can deal with, because these 2 functions over here are kind of bothering me. So I'm going to square both sides, and I think I can handle that. And what are you going to get? Well, you're going to get cosine squared beta, that's from this over here, plus sine squared beta. I got these guys. Let me get my eraser. I don't need to check those, do I? This is the tough part, though. And what are you going to get? Well, you can get plus or minus 2 cosine beta sine beta. And on the other side, you get a half. All right, let's take a look. This, I know what it is, just the number 1. That's true for all beta, by the way. Doesn't answer the beta question, though, by the way. So I'm going to get plus or minus 2 cosine beta sine beta. I'm going to take 1 from minus 1/2. Well, I'm going to multiply both sides by minus 1. You're still going to get plus or minus. All right. I know an identity for this. And the identity for this is going to be, let me write this at plus or minus the sine of, 2 beta, right? That's a known identity. And that's 1/2. So the sine of 2 beta is plus or minus 1/2. Well, you know what? I want to talk about the smallest possible value here. Now, before I do that, I want to claim to you the sine function looks like this over here, and I'm looking. The smallest thing I could hope for over here would be a half, right? That'd be the smallest beta. And where does a half occur? Let me write this down. In what reference angle do I get a half? That would be, let's see, that would be 30 degrees, right? Well, I can't speak in degrees, but that's going to be pi over 6. All right? So I'm going to say 2 beta would be equal to pi over 6. This is still going to be the smallest value because that's what they want, the smallest value. So what's beta going to be equal to? Pi over 12. All right? Let's see how we did. That's a tricky problem now. Boy, they did a lot of work over there, didn't they? Let's see if they got the answer down. Yeah, right over here. By the way, the work they put down there, that's one day I did the work that way, another day I do work another way. It depends how you want to do the work, all right? And again, the minimum pi over 12. I can't say one method's better than another. Again, it depends what day of the week you're working on the problem, I guess. All right, so I think I'm done with none. I got that one right too. And now what I'm going to do, I'm going to attack that problem with these powers in it. And I'm going to get my eraser out. I'm going to have to erase this business over here. We got one last problem to do. And I know it's going on for some time, right? And the problem with these problems for me is, by the way, I'll be honest with you, is the powers. They're kind of disturbing to me. And I'm looking at it, and the first thing I want to do is I want to write down that maybe something a little bit easier for me to handle. And I'm going to write this over here. I'm going to say let x equal, and we're doing number 4 now, the sine squared of alpha. Sorry about that. Now, someone says, why are you doing that? It's a way to get rid of those abstractions in the problem. And what would you get? You would get x, let's see, that would be sine squared. So that's going to be x to the 1008. Again, if you raised this to 1008, that would be 1008 times 2, which is 2016. So that seems pretty reasonable to me. I got troubles, though. And I'll tell you what my troubles are. I'm seeing this thing over here, this cosine thing. So I want to write down, the cosine. Right, I'll write this over here. The cosine squared of alpha. Well, what would that equal? That would equal 1 minus sine squared alpha. That's Pythagorean identity. So that would be the same thing as 1 minus x. All right? And then what's it going to be? It's going to be 1 minus x raised to what power? Well, 1008. All right. Now, Grant, I realize you're saying, why would you do that? It makes it easier for me. And what I'm going to do, I have to go back, but really what I'm trying to do is I'm trying to compute the minimum value now. And this is a function of x. Right, I can minimize that, and the way I'm going to do that is calculus. So write down f prime of x equals 1008 x to the 1007, and then it's going to be minus 1008, 1 minus x to the 1007. All right, let's keep thinking. By the way, before I go forward, I want to tell you, though, that if x is equal to sine squared of alpha, and we're in a real number system, that the x has to be between 0 and 1. All right, let me keep going. I'm going to look for the critical numbers. So really we're looking for 1008x to the 1007 is equal to 1008, 1 minus x to the 1007. All right, let's keep going. And I would get x to the 1007 and 1 minus x to the 1007. Well, that means x is equal to 1 minus x, which means 2x is equal to 1, which means x is equal to 1/2. Let me go back over here. X is equal to 1/2 is equal to sine squared alpha. Well, before I go forward, I probably should show between the intervals 0 and 1, this is 1/2, that would be a minimal value. I'll pick a number, let me take a look. It's going to be negative over here. Looking at the derivative. I'm looking at the derivative over here. Yeah, positive. It's minimal value. All right? Let me keep going. Sine of alpha. Oh, you know, I don't think I need to do that. Actually, I should do it. I'm sorry. Whether I need to do it or not, incidental. Plus or minus 1 over root 2. Do I need to know what alpha is, though? What's your question over here? Compute the minimum value. No, I don't need to find alpha. I just need to compute the minimum value, right? And let's see if we can do that. And I got this, right? So what's the sine of 2016 then? Alpha. Well, it's going to be 1 over 2 to the 1008. Yep. Let's do the other guy, which is the cosine. And I think we did that over here, right? So the cosine of 2016 alpha is going to be 1 and where's that? Oh, it's right over here. It's going to be the same thing. I got to add these together now. So the minimum value, add those two together. So 1 over 2, 1008, plus 1 over 2, 1008. If I add those two together, I get 2 over 2, 1008, which is going to be 1 over 2 to the 1007. All right, let's look at the key, see how we did. What number was that again? That was number 4, right? So I'm hoping to get that answer. By the way, when I look at the work too, I may say, gee, I did something different there. It's possible. A lot of work, didn't I? All right. Yeah, by the way, I did a lot more work than I did on the little talk we just did. All right, we're doing okay, though. All right, what does that mean? We completed them all out. I grant that, sometimes when I'm typing things up, I make mistakes. Sometimes I'm speaking to make mistakes. It happens. And again, this is just, it's kind of a rough view of what people do when they're exercising. It's a rough view. All right. My email address, if you need to reach out to me, is Bannon. That's B as in boy, the @ symbol, NNON.US. If you reach out to me and I'm not too busy, I'll get back to you. This document, though, is only made available at this point in time to the participants in the prison mathematics project. All right. But at some point, it'll be published. Probably if you reach out to me, I'll inform you when it's going to get published. But right now, I'm still vetting the content of it. And this is stuff I collected over years and time. There's definitely mistakes in the document. There's no doubt about it. There's certainly mistakes in these videos too, by the way. I'm kind of just, I'm not going to say rapidly going through it, but going through it, sometimes I'm going through them cold. I'm not looking at the answers. Other times I look at the work and say, well, I want to do them different, whatever. It's not the same, all right? And again, mistakes in speaking and in writing can happen, by the way. But this was an interesting problem set. In hindsight, looking back over it, if I were to determine the problems that were easiest for me to do, I'm going to say 3 was easy, 2 wasn't that bad, 5 was a bit tricky, 1 in hindsight wasn't that bad, and you know what? 4 really wasn't that bad, provided I did a substitution on it. But again, if you don't see those things, you could be here all day looking at it, wondering how to do the problem, taking all kinds of dead ends. Dead ends happen. If you're in a dead end, my gut feeling is at least have the sense to turn back and try a different road. All right, please. Thanks for paying attention, though.